Hello? Testing? Hi. Oh, hi. Coffee Cafe, you're here. You can hear me, right? I was reading your chat just now. Yeah. Sorry. Could I make a suggestion for Twitch, though? I do like your icon, but I think if it had any color, we could more easily see when you're streaming. Do you mean... Oh, thanks. Do you mean if the icon had color? Yes, that's what you meant. Because it is white, and white is a color, so there's that. But I think I see what you mean. What happened to... Hello? Okay. Something happened. Okay. Oh, she's awake, I think. Sure, no worries. No worries at all. Does Twitch have issues? You moved to YouTube. And the issue is on my side because streaming. Dropping frames and all that. Okay. Hello world. Good time of day. Whether it is... Stream is not doing well. No, it's my fault. It's 100% my fault. I can see 50% drop frames and... Okay, kilobyte per second is sometimes yellow, sometimes red, and sometimes green, just like traffic lights. Okay, we have a cat today. Should I go lower so that you can see the star? There's a star. Okay, good time of day. Color thing, if like Twitch shows streamer icons on the left, yeah. In black and white when not streaming, and okay, now I understand what you're saying. Honestly, I didn't. Makes sense. Oh, the cat helped. That makes sense. Okay, thank you. No, no, I just have to make my internet better, which I've been meaning to do without even, the Twitch streaming and all that. I probably stole it from Sailor Moon. I have no idea. This app has themed updates. I don't know if the cat is from Sailor Moon. I can check. Why is it not coming up? Wearing. It's an accessory. It does not say. I like this one. It makes it look like... It's funny, right? I can't always use it, but like I can't choose things on demand. I have to I don't know how to choose them on demand yet. Yeah, so I can't really turn them into the thing where... What is it called? The thing. Channel points? Bits? What I stream on? not sure, honestly. Because, you mean my laptop? It's Mac M1. Yeah. And the cat's here. It's been a week of me doing zero learning, and I need to get back. So I have put off going back to streaming until I can upgrade my avatar. You should do the same idea. Like I said, I did not create this avatar. It's from an app, a mobile app. And I think I put it in the name of the mobile app, but I can also, I'm quite sure that I did. Yeah, ZEPETO, something like that. ZEPETO. I put tools in the description in case anyone's curious. Okay, so you can upgrade your avatar that way. I hope you are encouraged by this. So, learning introduction to machine learning for coders. That's what I'm supposed to be doing. But am I? I don't know. Yeah, the course taught by Jeremy Howard on fast.ai. And we are in lesson 9. Almost like at the end. I was checking, like, I have like 15 minutes left of this lesson, and then we can go to I'm determined. I'll write on my MLKit app to track my face with my phone. I mean, you can, but the app does it for you. I don't know if you think it's doing an okay job or not. See, I'm smiling. But why reinvent the wheel when someone's already made it? But if you want to have all the control, this app probably has limits. You can. But you can start somewhere, and then, yeah, you can even do the, maybe not actually. I was thinking you can even do the face tracking on stream, but maybe not, I don't know. Lesson 10 will probably be fun. Lesson 9 is we're supposed to be at the end, and we did nothing NLP related, so I don't know. We were doing matrix related things. Matrix multiplication, matrix summing up. And lesson 10 should be more NLP, so I'm gonna play it and see where that goes. Go back 5 seconds. How's the stream right now, by the way? Is it same old or okay? Ooh, it says unstable. Lovely. Okay, Twitch is telling me that it is unstable.
Through in simple things like how do we create a grid in NumPy. So that's broadcasting. And so what we can do with this now is use this to implement matrix multiplication ourselves. Okay. Now, why would we want to do that? Well, obviously we don't, right? Matrix multiplication has already been handled perfectly nicely for us by our libraries. But very often...
Thank you. I'm glad it's pretty smooth. And I'm sorry for making you switch from one app to the other just to understand what I'm saying. Must be annoying.
You'll find in all kinds of areas in machine learning, and particularly in deep learning, that there'll be particular types of linear function that you want to do that aren't quite done for you, right? So for example, there's like whole areas called like tensor regression and tensor decomposition, which are really being developed a lot at the moment, and they're kind of talking about like how do we take like higher rank tensors and kind of turn them into combinations of rows, columns, and faces. And it turns out that when you can kind of do this, you can basically like deal with really high dimensional data structures with not much memory and not much computation time. For example, there's a really terrific library.
Sure.
Called Tensorly, which does a whole lot of this kind of stuff for you. So it's a really, really important area. It covers like all of deep learning, lots of modern machine learning in general. And so even though you're not going to like define matrix multiplication, you're very likely to want to define some other slightly different tensor product, you know. So it's really useful to kind of understand how to do that. So let's go back and look at our matrix and our 2D array and 1D array, rank 2 tensor, rank 1 tensor. And remember, we can do a matrix multiplication using the @ sign,
right,
or the old way, np.matmul. Okay. And so what that's actually doing when we do that is we're basically saying, okay, 1 times 10 plus 2 times 20 plus 3 times 30 is 140.
Oh, okay. What about the other row?
Right, and so we do that for each row, and we can go through and do the same thing for the next one and for the next one to get our result. Right?
Oh.
You could do that in Torch as well. We could make this a little shorter. Okay, same thing.
That T stands for tensor, right?
Okay, but that is not
Torch?
matrix multiplication. What's that? Sorry? Element-wise, specifically, we've got a matrix and a vector, so broadcasting. Okay, good. So we've got, this is element-wise with broadcasting. But notice the numbers it's created, 10, 40, 90, are the exact 3 numbers that I needed to calculate when I did that first piece of my matrix multiplication. So in other words, if we sum this over the columns, which is axis equals 1, we get our matrix vector product. Okay? So we can kind of do this stuff without special help from our library. So now let's expand this out to a matrix-matrix product. So a matrix...
Right. Up until now we've been matrix and array. Now we're doing matrix-matrix. Okay.
Matrix-matrix product looks like this. This is this great site called matrixmultiplication.xyz.
Ah.
And
I've already watched this, but I don't mind watching it again because it looks really pretty.
it shows us this is what happens when we multiply 2 matrices. Okay, that's what
Each row with each row. Okay.
matrix multiplication is, operationally speaking. So in other words, what we just did there was we first of all took the first column with the first row
Oh, right.
to get this one,
You flip it first. Okay.
and then we took the second column with the first row to get that one. Right? So we're basically doing...
Yeah, you did? No worries. It's making oh god, this motorcycle is being really loud. Can you move? I feel like it's standing right behind me. Broadcasting. When you take an array and do a mathematic function, I don't know, like with it, with a matrix, you have to make the array look bigger. So if it's like 1 by 3, you basically duplicate the 1 3 times. No, that was bad explanation.
The thing we just did, the matrix vector product, we're just doing it twice, right? Once.
This is a motorcycle, right? You can hear it, right? Okay, it's quiet now.
With this column, and once with this column, and then we concatenate the two together. Okay, so we can now go ahead and do that, like so. M times the first column dot sum, M times the second column dot sum. And so there are the two columns of our matrix multiplication. Okay, so I didn't want to like make our code too messy, so I'm not going to actually like use that, but like we have it there now.
Isn't it already there? I mean, it's nice when we're learning how to do it ourselves, but I think it's already there, right?
If we want to, we don't need to use torch or numpy matrix multiplication anymore. We've got our own that we can use using nothing but element-wise operations, broadcasting.
Sorry. I mean, right now it should be okay, but you're right, it might just keep going up and down. It's okay though. No worries, no worries. Thank you. You can sometimes say, what did you say? I don't mind. And even if you didn't hear my what did you say part, you can say what did you say. Yeah. And if you got questions, I will try to answer. And yeah, no worries.
And sum. Okay.
Okay. Are we going?
So this is our logistic regression from scratch class. Again, I just copied it here. Here's where we instantiate the object, copy it to the GPU. We create an optimizer, which we'll learn about in a moment, and we call fit. Okay, so the goal is to now repeat this without needing to call fit.
Why?
So to do that, we're going to need a loop which grabs a mini batch of data at a time, and with each mini batch of data we need to pass it to the optimizer and say, please try to come up with a slightly better set of predictions for this mini batch. Right? So as we learnt, in order to grab a mini batch of the training set at a time, we have to ask the model data object for the training data loader. We have to wrap it in iter to create an iterator or a generator.
Yep.
And so that gives us our data loader. Okay, so PyTorch calls this a data loader. We actually wrote our own fast.ai data loader, but it's basically the same idea.
Okay.
And so the next thing we do is we grab the x and the y tensor, the next one from our data loader. Okay.
I really like the way he says data loader, because it's Australian accent. Okay.
Wrap it in a variable to say, I need to be able to take the derivative of the calculations using this, because if I can't take the derivative, then I can't get the gradients and I can't update the weights. Right? And I need to put it on the GPU because my module is on the GPU.
Right.
And so we can now take that variable and pass it to the object that we instantiated. our logistic regression. Remember, our module, we can use it as if it's a function, because that's how PyTorch works. And that gives us a set of predictions, as we've seen before. Okay? So now we can check the loss, and the loss we defined as being a negative log likelihood loss object. Okay, and we're going to learn about how that's calculated in the next lesson. For now, think of it just like root mean squared error, but for classification problems. So we can call that also just like a function. So you can kind of see this very general idea in PyTorch that, you know, kind of treat everything ideally like it's a function. So in this case, we have a loss, negative log likelihood loss object. We could treat it like a function. We pass in our predictions, and we pass in our actuals. Right? And again, the actuals need to be turned into a variable and put on the GPU, because the loss is specifically the thing that we actually want to take the derivative of. Right? So that gives us our loss. And there it is. That's our loss, 2.43. Okay. So it's a variable. And because it's a variable, it knows how it was calculated. Right? It knows it was calculated with this loss function. It knows that the predictions were calculated with this network. It knows that this network consisted of these operations. And so we can get the gradient automatically. Right? So to get the gradient, we call L.backward. Remember, L is the thing that contains our loss. Right? So L.backward is something which is added to anything that's a variable. You can call .backward, and that says, please calculate the gradients. Okay? And so that calculates the gradients and stores them inside that
before the backward pass, use the optimizer object to zero all the gradients for the variable. It will update which are the learnable weights from the model. Zero gradient, okay. Backward pass, compute gradient of the lost with respect to models. Okay.
Basically, for each of the weights that was used, each of the parameters that was used to calculate that, it's now stored a .grad. We'll see it later. It's basically stored the gradient, right? So we can then call optimizer.step, and we're going to do this step manually shortly, and that's the bit that says, please make the weights a little bit better, right? And so what optimizer.step is doing is it's saying, like, okay, if you had like a really simple function like this, right, then what the optimizer does is it says, okay, let's pick a random starting point, right,
and optimize,
and let's calculate the value of the loss, right? So here's our parameter, here's our loss, right? Let's take the derivative, right? The derivative tells us which way is down, so it tells us we need to go that direction. Okay, and we take a small step, and then we take the derivative again, and we take a small step. Derivative again, take a small step. Derivative again, take a small step, until eventually we're taking such small steps that we stop. Okay, so that's what gradient descent does.
Yes.
Okay. How big a step is a small step? Well, we basically take the derivative here, so let's say derivative there is like 8, right? And we multiply it by a small number, like say 0.01, and that tells us what step size to take. This small number here is called the learning rate, and it's the most important hyperparameter to set. Right? If you pick too small a learning rate, then your steps down are going to be like tiny, and it's going to take you forever. Right? Too big a learning rate, and you'll jump too far. Right? And then you'll jump too far, and you'll diverge rather than converge. Okay? We're not going to talk about how to pick a learning rate in this class, but in the deep learning class we actually show you a specific technique that very reliably picks a very good learning rate.
Okay.
So that's basically what's happening, right? So we calculate the derivatives and we call the optimizer that does a step, in other words, update the weights based on the gradients and the learning rate.
Mm-hmm.
We should hopefully find that after doing that, we have a better loss than we did before. So I just reran this and got a loss here of 4.16. And after one step, it's now 4.03. Okay, so it worked the way we hoped it would based on this mini batch. It updated all of the weights in our network to be a little better than they were, as a result of which our loss went down. Okay?
Cool.
So let's turn that into a training loop. Right? We're going to go through 100.
Which was it that you wanted to know? And did you lose it? Or did he not? Oh, the learning rate part. Ah. Yeah, no, sometimes he's like, go to the deep learning class. Don't expect to get everything here. Hi, Mustafa. Start with a big learning rate and reduce it over time. Really? But what if you're already somewhere that's pretty close? Yeah, you're probably right though.
Steps, grab one more mini batch of data from the data loader, calculate our predictions from our network, calculate our loss from the predictions and the actuals. Every 10 goes, we'll print out the accuracy, just take the mean of whether they're equal or not.
Oh wait, I lost what he's talking about. Learning rate schedule, is that a thing?
So let's turn that into a training loop.
Ah, training
right?
loop.
We're going to go through 100 steps, grab one more mini batch of data from the data loader, calculate our predictions from our network.
Don't apologize. Like many recommend, like small, big, and back to small. Like, triangle or cosine. Something about, I don't know what that is. What is that? Huh. Has to do with material science. Heating it, cooling it, right? I think. Cool.
Calculate our loss from the predictions and the actuals.
Mm-hmm.
Every 10 goes, we'll print out the accuracy.
Oh, we're training it multiple times, aren't we? And accuracy should go up, loss should go down. Ooh.
Just take the mean of whether they're equal or not. One PyTorch specific thing, you have to zero the gradients. Basically, you can have networks where like you've got lots of different loss functions that you might want to add all of the gradients together, right? So you have to tell PyTorch.
Heat up metal to make it stronger, but it gets used in like data science metaphorically. Anal? That's cool. I had no idea.
Like when to set the gradients back to 0, right? So this just says set all the gradients to 0, calculate the gradients, that's called backward, and then take one step of the optimizer, so update the weights using the gradients and the learning rate.
And we're doing it 100 times, just for the fun of it?
And so once we run it, you can see the loss goes down, and the accuracy goes up. Okay?
Okay.
So that's the basic approach. And so next lesson, we'll see what that does. All right? We'll look at it in detail. We're not going to look inside here. As I say, we're going to basically take the calculation of the derivatives as a given, right? But basically, what's happening there, in any kind of deep network, you have kind of like a function that's like, a linear function, and then you pass the output of that into another function that might be like a ReLU, and you pass the output of that into another function That might be another linear layer. You pass that into another function. That might be another ReLU, and so forth, right? So like these deep networks are just functions of functions of functions. So you could write them mathematically like that, right?
And also loops. Functions, 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 and loops.
And so all backprop does is it says, let's just simplify this down to the 2 version, is we can say, okay, u equals f of x, right? And so therefore the derivative of g of f of x is we can calculate with the chain rule as being
every input has some loss landscape, and what we want is like the aggregate landscape, so just finding the minimum for any single data point is not what is wanted. Right.
g dash u f dash x, right?
You mean like the local, I forgot the word, and then there's a global, like smallest point, I forgot.
And so you can see we can do the same thing for the functions of the functions of the functions. And so when you apply a function to a function of a function, you can take the derivative just by taking the product of the derivatives of each of those layers. Okay, and
it's important to like step a little with each piece of data, I think, to find the minimum, local minima, something like that, I think, yeah, or local maxima, yeah, of data collectively.
And in neural networks, we call this backpropagation.
Oh.
Okay, so when you hear backpropagation, it just means use the chain rule to calculate the derivatives.
Okay.
And so when you...
sometimes he's talking about math things and it just goes over my head because I never learned it from, like learning it, the English word for it.
You see a neural network defined like here, right? Like if it's defined sequentially, literally all this means is apply this function to the input, apply this function to that, apply this function to that, apply this function to that.
Right.
Right, so this is just defining a composition of a function to a function to a function to a function.
We're basically choosing what is in each layer, right?
Okay, and so so although we're not going to bother with calculating the gradients ourselves, you can now see why it can do it, right? As long as it has internally, it knows like what's the derivative of to the power of, what's the derivative of sine, what's the derivative of plus, and so forth. Then our Python code in here is just combining those things together. So it just needs to know how to compose them together with the chain rule, and away it goes.
It was not Arabic, no. It was a different language. I don't know if I've ever said it though. Yeah, my English is good because movies. Or the internet, both. It's normal amount of nosy. Yeah. One must always answer to greeting. It's khair.
Okay. Okay, so I think we can leave it there for now, and in the next class we'll go and we'll see how to write our own optimizer, and then we'll have solved MNIST from scratch ourselves. See you then.
Cool. Going to the next lesson because I have the time. Yeah, movies, games, TV shows, songs, whatever is out there, you name it. books, everything. And also sometimes school. That's sometimes good, not always though. Sometimes school helps with like learning basics and like rules. Yeah. To lesson 10, I don't think we delved into NLP to say we'll develop our NLP model. Okay, if you call MNIST NLP, sure, but I wouldn't. Combining the strength of naive Bayes and logistic regression together, creating a hybrid, I have no idea what this is, MBSVM model, which is a very strong baseline of text classification. Okay, text classification, cool. Still, yeah, thank you. Like if I watch an anime or two, I barely know any Japanese. The thing is with English, it's literally everywhere, and when you grow up with it, because like it's not always just movies and internet, it's also you wanting to learn it. There are people who grew up same age, same access, didn't really have the interest, but what I wanted to say, what is it that I wanted to say? Yeah, I don't think it's as easy for other languages, especially if you don't grow up with it. The part of starting early is also pretty important, because I'm still answering your language question, even though the subject is changed. Because like I'm doing the same thing with Korean, trying to learn Korean from dramas and songs and movies and all that, and the progress is super slow compared to English. Okay, now I'm going to get to the other chat. I also know barely any Japanese, and I've watched a bunch of anime, but the interest for me is not there for Japanese, but it's totally there for Korean. MNIST is an NLP, thank you. Maybe there are exercises or text that goes into the missing stuff. Let's see. The digit recognition problem should be computer vision. It is computer vision. I agree with you. I love the sound of Korean language. 나도요. 저 한국어 배우고 싶어요. And that means I want to learn Korean. In the second half of the lesson, let's not get carried away. Let's just go first half.
Well, welcome.
I was literally like contemplating doing a Duolingo stream of Korean, or like a stream where I only try speaking Korean, because I have no one to talk to. But this is more important. I love Korean, but this is more important for me.
Well, welcome back to machine learning. One of the most exciting things this week, almost certainly the most exciting thing this week, is that fast.ai is now on pip. So you can pip install fast.ai. And so thank you.
I really do like how Korean sounds. Yeah, I agree. Languages sound different. And I also like the way Korean people speak. It feels like it's full of emotion. Even, I don't know if I'm like stereotyping, but the way, intonation sounds pretty cool.
To Prince and to Karem for making that happen. To USF students who had never published a pip package before, and this is one of the harder ones to publish because it's got a lot of dependencies. So it's probably still easiest just to do the conda env update thing, but a couple of places that it would be handy instead to pip install fast.ai would be, well, obviously if you're working outside of the repo and the notebooks, then this gives you access to fast.ai everywhere. Also, I believe they submitted a pull request to Kaggle to try and get it added to the Kaggle kernels, so hopefully you'll be able to use it on Kaggle kernels soon. Yeah, you can use it at your work or
Isn't it already there? I mean, this is 2018, so yeah.
whatever else. So that's exciting. I mean, I'm not going to say it's like released yet. You know, it's still very early, obviously, and you're helping add documentation and all that kind of stuff. But it's great that that's now there. Couple of cool kernels from USF students this week.
Cool kernels.
Thought I'd highlight two that were both from the text normalization competition, which was about trying to take text which was written out, just standard English text. They also had one for Russian, and you're trying to kind of identify things that could be like first, second, third, and say like that's a cardinal number, or this is a phone number, or whatever. And I did a quick little bit of searching, and I saw that there had been some attempts in academia to use deep learning for this, but they hadn't managed to make much progress.
On the screen shows the status as alpha? What do we mean? I don't know what you mean.
And I actually noticed, so Alvira's kernel here, which gets 0.992 on the leaderboard, which I think is like top 20.
Oh, sorry. The version is not even beta. Okay.
It's kind of entirely heuristic, and it's a great example of kind of feature engineering. In this case, the whole thing is basically entirely feature engineering. So it's basically looking through and using lots of regular expressions to figure out for each token, what is it, and I think she's done a great job here of kind of laying it all out clearly as to what all the different pieces are and how they all fit together. And she mentioned that she's maybe hoping to turn this into a library, which I think would be great, right? You could use this to grab a piece of text and pull out what are all the pieces in it. It's the kind of thing that the natural language processing community hopes to be able to do without like lots of handwritten code like this. But for now, it'll be interesting to see like what the winners turn out to have done. But I haven't seen machine learning being used really to do this particularly well. Perhaps the best approaches are ones which combine this kind of feature engineering along with some machine learning. But I think this is a great example of effective feature engineering. And this is another USF student who has done much the same thing, got a similar kind of score, but used her own different set of rules. Again, this would get you a good leaderboard position with these as well. So I thought that was interesting to see examples of some of our students entering a competition and getting kind of top 20-ish results by, basically just handwritten heuristics. And this is where...
Yes, it's aged, you can tell. Yeah. And it's not a few years, isn't it? 5 years? It's 5 years. 2018 is not 2 years ago, it's 5 years ago.
For example, computer vision was 6 years ago still. Basically all the best approaches was a whole lot of like carefully handwritten heuristics, often combined with some simple machine learning. And so I think over time...
Yes, yeah. One day models might be able to learn without the handwritten stuff. Yeah, today's the day.
The field is kind of definitely trying to move towards automating much more of this. And actually, interestingly, very interestingly, in the safe driver prediction competition, which just finished, one of the Netflix prize winners won this competition, and he invented a new algorithm for dealing with structured data, which basically doesn't require any feature engineering at all. So he came first place using nothing but 5 deep learning models and 1 gradient boosting machine. And his basic approach was very similar to what we've been learning in this class so far and what we'll be learning also tomorrow, which is using fully connected neural networks and one-hot encoding, and specifically embedding, which we'll learn about. But he had a very clever technique, which was, there was a lot of data in this competition, which was...
Here's the cool thing, his classes, like he's showing things that are actually happening now. To him, obviously, he can't show things in the future. But like showing his students, this is a competition that was won recently, and this is what he did. How cool is that?
Was unlabeled. So in other words, where they didn't know.
Ask ChatGPT to write. Yeah, basically. Yeah, that's 2023 version.
Whether that driver would go under claim or not, or whatever. So unlabeled data. So when you've got some labeled and some unlabeled data, we call that semi-supervised learning. And in real life, most learning is semi-supervised learning. Like in real life, normally you have some things that are labeled and some things that are unlabeled. So this is kind of the most practically useful kind of learning. And then structured data is the most common kind of data that companies deal with day to day. So the fact that this competition was a semi-supervised structured data competition made it incredibly practically useful. And so what his technique for winning this was...
semi-structured. I realized that Jeffrey L. Hinton giving like perks to every student he has had to I don't think I've watched many of his talks, but when teachers do that, you know that they're great people. Besides being smart and like good teachers, they're just great people. Like they're proud of their students. I mean, this is them telling what's happening. It's not a student, I think. I don't think their student did this, but three of the other things he was showing were from his students.
To do data augmentation, which those of you doing the deep learning course have learned about, which is basically the idea, like if you had pictures, you would like flip them horizontally or rotate them a bit. Data augmentation means creating new data examples, which are kind of slightly different versions of ones you already have. And the way he did it was for each row in the data, he would like at random replace 15% of the...
Oh, I should watch some of his talks. Thank you.
Variables with a different row. So each row now would represent like a mix of like 80%, 85% of the original row, but 15% randomly selected from a different row. And so this was a way of like randomly changing the data a little bit. And then he used something called an autoencoder, which we will probably won't study until part 2 of the deep learning course. But the basic idea of an autoencoder is your dependent variable is the same as your independent variable. So in other words, you try to predict your input, which obviously is trivial if you're allowed to the identity transform, for example, trivially predicts the input. But the trick with an autoencoder is to have less activations in at least one of your layers than your input, right? So if your input was like...
When did Attention is All You Need come out? It was before 2020, obviously. Attention is All You Need. Okay, yeah, it existed during this. Got it.
A 100-dimensional vector, and you put it through a 100 pi 10 matrix to create 10 activations, and then had to recreate the original 100-long vector from that. Then you've basically you've had to have compressed it effectively. And so it turns out that that kind of neural network is forced to find correlations and features and interesting relationships in the data, even when it's not labeled.
Okay.
So he used that rather than he didn't do any hand engineering. He just used an autoencoder. These are some interesting kind of directions that if you keep going with your machine learning studies, particularly if you do part 2 of the deep learning course next year, you'll learn about. You can kind of see how feature engineering is going away. And this was just an hour ago. So this
Ah,
is very recent news indeed.
wow. I was like, this hour ago is real. It is real. And he's saying feature engineering is going away because you can now work with unstructured, semi-structured data without needing to understand it. It's all both like sad and great at the same time.
Indeed. But this is one of the most important breakthroughs I've seen in a long time.
Oh.
Okay. So we were working through a simple logistic regression trained with SGD for MNIST.
Still MNIST, yes.
And here's the summary of where we got to. We have nearly built a module, and a training loop from scratch. And we were going to kind of try and finish that. And after we finish that, I'm then going to go through this entire notebook backwards, right? So having gone like top to bottom, we're then going to go back through bottom to top.
Okay.
Right? So,
I could be wrong, but I seem to think when I spend a little time around, this time to understand where ML might be at, Kaggle was often won by like simpler algorithms like random forests. Recently, I don't know what's happening in Kaggle, honestly. Do you think it has to do with explainability? Like them needing to understand what's happening, how decisions are being made? Or are they, I don't know. Why do we think they're not using more complex things? I have no idea. Oh, could be also resource limitations. Do you think Kaggle people who do Kaggle competitions have the same amount of resources as Facebook, Google researchers, Microsoft, these people, OpenAI, DeepMind?
this was that little
Okay, yeah, this is 5-6 years ago as well. So we are both looking at the same timeline. No worries.
handwritten nn.module class we created. We defined our loss, we defined our learning rate, and we defined our optimizer. And this is the thing that we're going to try and write by hand.
I think like random forest is cheap on resources, and yeah, data maybe. That and explainability part is also important. What just happened? Oh my god. Why is there a line next to me? What did I do? I have no idea. Is the line here as well? Oh yes. Wait, it's on both sides. Why is the world becoming smaller?
And in a moment. So that stuff, that we're dealing with from PyTorch, but that we've written ourselves, and this we've written ourselves. So the basic idea was we're going to go through some number of epochs. So let's go through one epoch, right? And we're going to keep track of how much for each mini batch, what was the loss, so that we can report it at the end. We're going to turn our training data loader into an iterator, so that we can loop through every mini batch. And so now we can go ahead and say for tensor in...
Oh, it's my fault. It's my fault I wore the striped shirt. Oh no. Will there be more bars? Help. It's actually fun for like hiding. Now I can hide behind something. Oh wow, it says your character has left the screen. Thank you. You can't see it, but I can. She's back, no worries. Okay. We're reviewing.
The length of the data loader.
Go
then we
back.
can loop through every mini batch. And so now we can go ahead and say for tensor in the length of the data loader. And then we can call next to grab the next independent variables and the dependent variables from our data loader, from that iterator. Okay. So then remember, we can then pass the X tensor into our model by calling the model as if it was a function. But first of all, we have to turn it into a variable. Last week, we were typing variable blah.CUDA to turn it into a variable. A shorthand for that is just the capital V. Right? So capital T for a tensor, capital V for a variable. That's just a shortcut in fast.ai.
Okay. Yeah.
So that returns our predictions.
I do remember the capital T for tensor, but not the capital V for variable.
And so the next thing we needed was to calculate our loss, because we can't calculate the derivatives of the loss if we haven't calculated the loss. So the loss takes the predictions and the actuals. Okay, so the actuals again are the Y tensor, and again we have to turn that into a variable. Now, can anybody remind me what a variable is and why we would want to use a variable here?
What a variable is? Isn't it the learning rate? No? I mean, a variable is a variable. Oh, we have learning rate right up here. I don't know. I was not focusing. Don't expect me to be a good student.
I think once you turn it into a variable, then it tracks it, so then you can do it backward on it. So you can
And what, sorry? When you turn to variable, it
can track like its process of like, you know, as you add the function, as the functions start getting layered within each other, you can track it, and then when you do backward on it, it back propagates and does the gradient boosting.
Right. So gradient boosting. Right. So a variable keeps track of all of the steps to get computed. And so there's actually a fantastic tutorial on the PyTorch website.
Mm-hmm.
So on the PyTorch website, there's a tutorials section, and there's a tutorial there about AutoGrad. AutoGrad is the name of the automatic differentiation package that comes with PyTorch.
Okay.
And it's an implementation of automatic differentiation. And so the variable class is really the key class here, because that's the thing that turns a tensor into something where we can keep track of its gradients. So basically here they show how to create a variable, do an operation to a variable, and then you can go back and actually look at the grad function, which is the function that it's keeping track of, basically to calculate the gradient, right? So as we do more and more operations to this variable, and the variable's calculated from that variable, it keeps keeping track of it. So later on we can go dot backward and then print dot grad and find out the gradient. Right? And so you notice we never defined the gradient, we just defined it as being x plus 2 squared times 3, whatever.
Okay.
And it can calculate the gradient.
That's pretty cool.
Okay, so that's why we need to turn that into a variable. So L is now
We're training the Y into a variable. Okay, got it.
a variable containing the loss. So it contains a single number for this mini batch, which is the loss for this mini batch. But it's not just a number. It's a number as a variable, so it's a number that knows how it was calculated. Right? So we're going to append that loss to our array just so we can get the average of it later, basically. And now we're going to calculate the gradient. So L dot backward is the thing that says calculate the gradient. So remember, when we call the network, it's actually calling our forward function. So that's like go through it forward, and then backward is like using the chain rule.
I don't think it existed when the course was made. What? Sorry. I don't keep track of my the things that I said. I'm not a variable.
So that's like go through it forward, and then backward is like using the chain rule to calculate the gradients backwards. Okay, and then this is the thing we're about to write, which is update the weights based on the gradients and the learning rate. Okay, zero grad will explain when
Updating the weights. Got it.
we write this out by hand. Okay. And so then at the end, we can turn our validation data loader into an iterator, and we can then go through its length.
Oh, I don't think you said that out loud. Google Colab, right? Yeah, I saw download. Seriously? You think? Oh, that's pretty new. No, don't be less chatty. It's good for the YouTube algorithm. I mean, be however much chatty as you want. I really don't mind. But yeah, it had like download to 1425. It had Python and Jupyter. Yeah, you're right.
Data loader into an iterator.
Colab will let you train for free in the cloud. Yeah, without like getting CUDA working on your PC. Yeah, I love Colab. Sometimes I use it, not as much, but yeah, it's like my go-to notebook style thing. I don't have Jupyter on my device.
And we can then go through its length, grabbing each x and y out of that, and asking for the score, which we defined up here to be equal to which thing did you predict, which thing was actual, and so check whether they're equal, right? And then the mean of that is going to be our accuracy. Okay.
Okay.
Could you pass that over to Chenxi?
What's the advantage that you convert it into an iterator rather than like use normal, I don't know, Python loop or?
We're using a normal Python loop.
Yeah.
So it's still this is a normal Python loop. So the question really is like, compared to what, right? So like, the alternative perhaps you're thinking of would be like we could use like something like a list with an index.
Yep, Kaggle kernels are also a nice place to train your model, and we've been doing that as well. So those two places are pretty cool.
Indexer. Okay. So, the problem there is that we want, there's a few things. I mean, one key one is we want each time we grab a new mini batch, we want it to be random. We want a different shuffled thing. So this, you can actually kind of iterate from forever. You can loop through it as many times as you like. So there's this kind of idea, it's called different things in different languages, but a lot of languages will call it like stream processing, and it's this basic idea that rather than saying I want the third thing or the ninth thing, it's just like I want the next thing, right? It's great for like network programming, it's like grab the next thing from the network. It's great for UI programming, it's like grab the next event whether somebody clicked a button.
Right.
It also turns out to be great for this kind of numeric programming, so it's like I just want the next batch of data. It means that the data can be kind of arbitrarily long because we're just grabbing one piece at a time.
Can it be sorted?
Yeah. So, and also, I guess the short answer is because it's how PyTorch works. PyTorch's data loaders are designed to be called in this way. And then so Python has this concept of a generator, which is like an type of generator.
That was funny.
I wonder if this is going to be a snake generator or a computer generator. Okay. A generator is a way that you can create a function that, as it says, behaves like an iterator. So like Python has recognized that this stream processing approach to programming is like super handy and helpful and supports it everywhere. So basically anywhere that you use a for in loop, anywhere you use a list comprehension, those things can always be generators or iterators. So by programming this way, we just get a lot of flexibility, I guess. Does that sound about right, Terence? You're the programming language expert. Did you?
Yeah, I was going to say something.
Do you want to grab that box so we can hear? So Terence actually does programming languages for a living, so we should ask him.
Yeah, I mean, the short answer is what you said. You might say something about space, but in this case, that all that data has to be in memory anyway, because we've got...
No, it doesn't.
Yeah, I mean, if you have a list of things and you just want to get it one by one, okay. But also some sort of sorting might be involved if it's necessary.
To be in memory, so in fact most of the time
we could pull a mini batch from something.
In fact most of the time with PyTorch the mini batch will be read from like separate images spread over your disk on demand, so most of the time it's not in memory.
But in general you want to keep as little in memory as possible at a time.
There's been some papers that seem to hint that easy data first, hierarchies later. I don't know. Whoa. Interesting.
And so the idea of stream processing also is great because you can do compositions, you can pipe the data to a different machine, you can...
Yeah, the composition's great. You can grab the next thing from here and then send it off to the next stream, which can then grab it and do something else.
It's like pipelining basically. And if you want to learn words, you want the word obviously, but you probably want to randomize the document. Yeah. But yeah, I guess I didn't really think about it. Iterating through the input. I see.
Yeah. Which you guys all recognize, of course, from the command line pipes and redirection. Yes.
Okay. Thanks, Terence. It's the benefit of working with people that actually know what they're talking about. All right. So let's now take that and get rid of the optimizer. Okay. So the only thing that we're going to be left with is the negative log likelihood loss function, which we could also replace. Actually, we have a implementation of that from scratch that Yannet wrote in the notebooks. So it's only one line of code, as we learned earlier. You can do it with a single if statement. Okay. So I don't know why I was so lazy as to include this. So what we're going to do is we're going to, again, grab this module that we've written ourselves, the logistic regression module. We're going to have one...
We're doing literally everything by hand. That's why writing the optimizer ourselves. Stochastic and stochastic gradient descent requires a fair amount of noise between each input. Okay. Okay.
Epoch, again, we're going to loop through each thing in our iterator. Again, we're going to grab our...
As a non-English speaker, the word epoch is pretty cool because it means... Yeah, it's a thing. It's a thing outside of computer science. Even though it says relevant epoch machine learning. I know, we stole everything. Particular period of time in history, like the Victorian epoch. Does it mean era? Like era? Yeah, basically like era. Unix time? Yes. The world started on January 1st, 1997. Unix epoch. Okay.
Independent and dependent variable for the mini batch. Again, pass it into our network. Again, calculate the loss. So this is all the same as before. But now we're going to get rid of this optimizer.step and we're going to do it by hand. So the basic trick is, as I mentioned, we're not going to do the calculus by hand.
I'll use a lot of words in ways that are kind of wrong, I guess. it just steals them and gives them new meaning, basically. Yeah.
So we'll call L.backward to calculate the gradients automatically.
Mm-hmm.
And that's going to fill in our weight matrix. So do you remember when we created our, let's go back and
I don't.
look at the code for, here's that module we built. So the weight matrix for the linear layer weights we called L, and for the bias we called L1B. Right? So they were the attributes we created. I've just put them into things called W and B just to save some typing, basically. So W is our weights, B is our biases.
Oh.
And so the weights, remember the weights are a variable, and to get the tensor out of the variable we have to use .data, right? So we want to update the actual tensor that's in this variable. So we say weights.data minus equals, so we want to go in the opposite direction to the gradient. The gradient tells us which way is up, we want to go down. Whatever is currently in
minus equals because we don't want to increase, we want to decrease. Okay.
gradients times the learning rate. So that is the formula for gradient descent. Right? So as you can see, it's like as easy a thing as you can possibly imagine.
That's the formula for gradient descent? Huh.
And it's like literally update the weights to be equal to whatever they are now minus the gradients times the
Learning rate.
And do the same thing for the bias.
Wow.
Does anybody have any questions about that step in terms of like why we do it?
My brain stopped. Learning rate minus weight times learning rate. Okay. Current minus weight times learning rate.
Or Howard, did you have a question? Do you want to grab that?
No, that step. But when we do the next of DL,
The next here?
yes, yes. So when we reach the end of the loop, how do we grab the next element?
So this is going through each index in range of length. So this is going 0, 1, 2, 3. At the end of this loop, it's going to print out the mean of the validation set, go back to the start of the epoch, at which point it's going to recreate a new iterator. Okay, so basically behind the scenes in
Yeah, getting... Seriously? People getting this formula tattooed? Wow. I mean, it's like it's like E equals MC squared, but not really. Sorta. Like not really.
Python, when you call iter on this, it basically tells it to like reset its state to create a new iterator.
Okay, now you just made me think of Senku's. Oh, what happened? Where's Senku from Dr. Stone? And his style of clothing. Of the... See? This here. Not really tattooed, but... Can you see it? Not so surprisingly, it's written in blood. Because he didn't have a pen with him. Don't blame him. Is he kind of cheating? Wasn't his PyTorch version using Adam? I don't know.
And if you're interested in how that works, the code is all available for you to look at. So we could look at like md.train.dl is a fast.ai.dataset.model data loader. So we could like take a look at the code of that.
Ooh. Alaikum assalam. Hi. What are we studying? I will let you know.
See.
For the atom, has extra terms for like momentum. I really don't know anything about it, Adam, sorry. We're studying Introduction to Machine Learning for Coders. It's a course by Jeremy, on fast.ai, taught by Jeremy Howard. Pretty cool thing. You can, I can send you the link in the chat and you can have a look around. Like, imagine a marble rolling down a hill. Huh. Okay. I mean, I wouldn't call it cheating, but what is Atom exactly? Like, is it a function? Is it a... What does it do? Thank you.
Exactly how it's being built, right? And so you can see here, here's the next function, right? Which basically...
Hold up, I could Google... Oh, sorry. I just got an... Huh. Okay. Yeah. Sorry for the lag. Life is like that. Also, my internet is like that. Name... Oh, okay. Okay, so it's an optimizer. I was about to Google it. Okay. Now I see what you're saying. Oh, adaptive optimizer? Huh. It is what I believe used before in PyTorch while his code is... Okay, so he was using ready-made things from PyTorch and... Okay. But he said we will write our own optimizer. 22, 27 is where we are at now. If I go back and show you, I think he stopped using the... Where is it? Where is it? I lost it, but I do remember seeing it. There. Now, instead of using the optimizer, we'll do the optimization ourselves. So it's not really... It's like go-to for most trainings. Huh. I didn't really know about Atom, sorry. Yeah, but I think he stopped using it. Yep. 22, 27, 22, 27. Okay.
Code of that and see exactly how it's being built, right? And so you can see here, here's the next function, right? Which basically is...
Study... Huh? Cool studies. Are you trying to build something AI related? Sorry, I saw your comment late. Mostly studying and like not now. Maybe trying to do Kaggle competitions. That would be pretty cool. But I'm not really there yet. Yeah. By the way, is your name Punch but with an E? That's a cool, cute name. Sorry, I did not think it would be obvious. This is my bad. No worries, no worries. Just pointing out this version was simpler. Yeah, obviously it's pretty, yeah, I guess bare bones maybe. Right. I guess, yeah, he wanted us to see how simple optimization is made, and I guess Atom could be a better version. I really don't know.
Keeping track of how many times it's been through in the self.i. And here's the iter function, which is the thing that gets called when you create a new iterator. And you can see it's basically passing it off to something else, which is a type data loader, and then you can check out data loader if you're interested to see how that's implemented as well.
Punch with an E. I just don't know how to read it. Yes, I am from... Where am I from? In Middle East. I thought you were asking, are you from Middle East? Sure, I don't mind saying that I'm from Iraq. Iraq in with an accent.
So the data loader that we wrote basically uses multi-threading to allow it to have multiple of these going on at the same time. It's actually it's really simple. It's only about a screen full of code. So if you're interested in simple multi-threaded programming, it's a good thing to look at. Okay, now, yes.
Why have you wrapped this in a for epoch in range 1, since that'll only run once?
Because in real life, we would normally be running multiple.
Oh, that's a good question, because it says range 1. That's pretty funny. Sorry, Coffee. Thing is, I've said where I'm from before, but thank you. You're being super kind. Yeah. But you'd be surprised how me saying what language I speak would zoom in more. Yeah. But thank you. That's really, 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 really sweet of you. I appreciate it.
Okay.
So like in this case, because it's a linear model, it actually basically
Sure. Why not? Nah. Though Iraqi CS student? Yeah, sure. I'm not really a CS student, by the way, but thank you. That's cool. Thank you. Good luck with me and with everyone who's here.
trains to...
I'm a no more CS student. I am a graduate. Well, graduated from graduate. Anyway.
as good as it's going to get in one epoch. So if I type 3 here, it actually...
I work. I'm a person who works, which then you're no longer a student. Yeah. But wish me luck. If you're going to wish me luck on getting accepted to a PhD program. I mean, inshallah, we'll see. Still waiting. It's been so long. I'm really angry, but it's fine.
It actually won't really improve after the first epoch much at all, as you can see, right? But when we go back up to the top, we're going to look at some slightly deeper and more interesting versions, which will take more epochs. So, if I was turning this into a function, I'd be going like, def train model, and one of the things you would pass in is like number of epochs, kind of a thing.
Yep.
Okay, great.
Okay, great. So, I'm thinking of stopping here, even though I don't have to. I don't know. Are with programming and probably ML, you are always learning. So yes, lifelong students. So always kind of a student, even when working. 100%, especially like when you are like a software developer, that thing never stops. There's always new things. I suppose even in my work, inshallah, may Allah grant it to you. We need more of that in our community. I mean, thank you. I really appreciate it. Yeah, no, there are a lot of smart people in our community. It really doesn't have to do with, I don't know. It's support, I suppose. Because not so happily I will be funding my own, like the tuition side, which is Not too much, but it's still not little. What are we going to go through here?
So one thing to remember is that when you're creating these neural network layers, and remember, like
yeah, I think I'm gonna punt. Sure. Thank you. Appreciate it. I like the number 79, and now there are 79 followers on Twitch, which is pretty cool. Yes. It's not really about... Yes, and now my brain stopped working. Let's get it back to working. Yeah, I wanted to stop here because I think we're getting into, according to the chapters down here, we might be getting into a new subject, and my brain is like, this is as much as I can take because I have some admin things that I need to do. Emails to write. But like for personal reasons, I like almost never work on weekends. Oh god, the prison is back. Yeah, so I need to go for that reason. Otherwise I do have time for more learning, but also I don't want to overload my brain. Weekends are supposed to be for relaxing. Okay, how long have I been streaming? Oh, okay, an hour and a half. Pretty okay. Because like YouTube for some reason keeps telling me it's been 1 hour and 17 minutes, which is not true. All right. Oh wow, I think currently the stream is pretty okay. Cool. Why did I lose the chat? There's a new chat. Will you... I should because will I do any coding? Because shut up, you're kidding. Oh, I should sign in. Got it. Oh, you can't see my screen. That's good. Yes, it is cool to see a model being trained. I will reshare the screen. Yes, so for this lesson we had this Kaggle, notebook style thing. No, it's not already ran. I think this is... Sorry. I keep moving so fast that I can't even see the... matrix multiplication is what we just did. Yes. There's Adam. You're right. Optimization was Adam. So this is what was... this is the 100. Yep, that's the epoch one. This is where we... Yeah, this is what we were looking at. For some reason I could not run getting the data, the MNIST data. Yeah, and I just stopped. I gave up. So if I don't do that, I will be able to at least run his code, because the lessons are available online to look at. So I don't know if I'll do it for MNIST or if we'll do it for if there's a next lesson. I don't know how many lessons, notebook wise, because video wise there are 12, but I don't know if it's 4 or 5 notebooks. If you go to the lesson wiki, sometimes they put the notebooks there. Okay, I don't know why it's loading, but oh, yeah, supposed to be there. I haven't checked Hugging Face, but Kaggle does have a copy. Yes, you're right. I haven't checked Hugging Face. Should we? Ooh, paper. Okay. Yeah, no, this one doesn't have it, I suppose. Oh. Wow. That's lesson 10? 11, okay. If I copy the name of this, Introduction to Machine Learning for Coders, and then say Hugging Face. Let's see what we get. Should not have done the space. No. Aww. As much as I'd love it, should have written fast.ai. Fast.ai. Not there. I don't see it. If you have a link, welcome to fast.ai. I mean, okay, so they have an introduction to deep reinforcement learning. Doesn't seem like it. This is a hub. Hey. Open in collab. Okay, they have collab. Oh, obviously. Huh. I think here we were getting it from like the main MNIST link. Yes, you're right. I don't know if it's on Hugging Face, but deeplearning.net, that's where they were getting it from. I actually didn't check if the link works, so you might be right. Yeah, no, not course material. Sure, I can try that next time. Thank you. That was pretty good advice. I don't know. For some reason the website asks for a password. Huh. Okay. We can say Hugging Face. Hugging Face MNIST. And I can just... Is this a path? Whoa! Homepage from Jan LeCun? Oh. This is the site that requests. Hold up. Oh wow, what? That's weird. Too many people learning ML for... Good point. but it's here. I doubt. Cool. We shall try this next time. What is the link? Wait, what? Did I just copy the title? Sheesh, I copied something else. Alright. We'll get there. I don't know how. We'll try. Yeah. I think we'll be able to get it from there. But that's... Oh! She's stuck again. Wake up. Oh, she's up. I think that's all for today. Thank you for all the chat and talking and the interesting conversations and the making of new friends and talking to old friends and getting old. Because, you know, when you give me more than an hour of your life, that's a lot. So I appreciate that. Yeah, happy Friday. It's a blessed day. It's a beautiful day. And sorry for just being MIA all week last week. I just had zero motivation. Sorry. Like, I just couldn't bring myself to learn new things. I was like, just Korean dramas, that's all I can do. Yeah. So thank you for being here. And inshallah, we'll be able to finish this course because we're like in lesson 10 and it's only 12 lessons. That's like, wow. I did not have faith in myself to get here. But here we are. Inshallah, I'll see you next time if you have the time and energy. If not, no worries. You can always watch the VODs or, you know, videos on whichever platform you prefer. And yeah, thank you. Today the cat was pretty nice, even though, oh, ma'asalama. Thank you for taking the time to stream. We really appreciate it. Oh, thanks. You don't have to appreciate me streaming. It's just me appreciating being here and you guys listening to me talk for hours. Wow, sorry. Okay, have a blessed Friday and enjoy your weekend. I hope it's the weekend. Oh, that's so sweet. I was like, wait, is he an Arab? That it was so sweet. Yeah. Mustafa, help us spell check this. Is the ma'asalama good? Because I'm cool with it. I can read it. That was sweet. So it's not the weekend for you, but yeah, happy the weekend that's close to come. Our cat did obstruct the view, but it was nice. We may have something else next time. Yeah, thank you. And I'm gonna end the stream starting from 10. If you have anything, let me know. I don't mind answering. And I'm really happy that the stream is pretty good right now. I don't know why it started off pretty bad, but I think it's pretty good. I hope. Yay, we got an all good from Mustafa. Lovely. Okay. Thank you. That was really sweet. I'm gonna end the stream in 10, 9, 8, 7, 5. Wait, no, it's 6. 5, 4, 3. Congratulations, you received 100. Wow, I've never gotten that. Ha, ma'asalama. Ooh, tashkil. That's a beautiful ma'asalama. Which is a thing, yeah, Google Translate doesn't give you the fatha, kasra, dhamma, and all the beautiful things that Arabic language has. that I can't read without. Like, honestly, I have a really hard time reading without it.